To start the MCR3U course, the grade 11 university stream math course, we're going to actually do several sections of review. This is going to primarily deal with material that you should have covered in your grade 10 course, and hopefully you remembered, or with a little bit of prompting and a little bit of review, will remember again. So the first thing we're going to be taking a look at here is a linear relation. There's a worksheet that goes along with this review, and I've attached that to the web page. So if you want to work on that on your own, you can go ahead and take a look at that. What we have here is a simple linear relation, which is a straight line, and I've arranged it so that the numbers work out fairly nicely for this. So the first thing that we want to do is we want to think about, well, what are the properties of a linear relation? So this is going to call on you to try to remember some of the things that you learned about linear relations in grade 9 and grade 10, just looking for, first of all, keywords, and then how do we match those keywords up with some actual numeric properties that go along with this. So when we look at a linear relation, the order that you do these things is up to you. Some things are more useful than others. So you might take a look at, for example, something like this point, which is known as the y-intercept. And we could also talk about this point here on the x-axis, which is obviously the x-intercept. And we're going to associate values with these things. And actually, you know what? While we're doing that, while we're speaking of it, why don't we go ahead and do that? So the y-intercept, well, where does that occur? It occurs at a y value of -5. So we have a y-intercept of y equals -5. We have an x-intercept, the x value here. Now you might wonder, it's between 7 and 8, but is it exactly between 7 and 8? And I don't know if you can see it clearly enough, but there are actually half value marks on this graph, and it is exactly at that point. So this is at x equals 7.5. Now there's another way we could have represented these intercepts, which is in coordinate form. So for example, I could have said that the y-intercept is actually a point with coordinates an x value of 0 and a y value of -5. And I could have said that the x-intercept has an x value of 7.5 and a y value of 0. Both of those are completely valid ways of expressing this. It just depends on what is the most useful way for you to communicate this information. Something else that we might be interested in when we're dealing with straight lines might be the slope. Now the slope actually has a number of components to it before we can get to it. When we talk about slope, we're probably going to be interested in what's known as the rise and the run. And so the rise is the vertical change that occurs. And the way to determine that, if you're looking at a graph, is you're going to want to take a look at a nice point. So in this case, I'm going to pick this point right here, and I'm going to look at what is the vertical change between that point and another nice point. And you can see here, so there's a horizontal change. So when we talk about rise, there is rise. Sorry, that didn't get written very nicely. So there's our rise, and then along here is the run. And it's because I'm writing over graphics here that things are slowing down quite a bit. So what is the rise here? And in this case, because this graph has been chosen to be as simple as possible, the rise is actually equal to 4. And in this case, the run is equal to 1, 2, 3, 4, 5, 6. And this is the rise and run as I've chosen it on this graph. There are other triangles that I could have drawn, but the important part is that the ratio of rise to run is going to be the same. And that gets us into the idea of slope, which is actually another way that we represent slope is the symbol m. and m is equal to rise over run. Another way of saying that is the delta y over delta x, the change in y coordinates over the change in x coordinates. And in this case, our change in y is 4, our change in x is 6, and we should reduce that fraction to 2/3. So this has a slope of 2/3. Now, what are some of the other properties? There may be a number of properties that you might see here. I'm also just going to put arrows on. The graphing program that I use doesn't actually put those arrows on automatically, but this line extends in both directions. So what are some of the other things you might notice? Well, we've actually already seen this from our calculation. From our calculation of slope, we can see that this is a positive number, so that means we have a positive slope. But we could have determined that without doing the calculation, just from observation, because this goes up and to the right. And another way that you might express that, you might also call that a positive correlation. That's drawing more on something that you would have talked about in perhaps grade 9 rather than grade 10, because in that case, what we're saying is as x gets bigger, as x increases, y also increases, and that's the positive correlation we're talking about. As x goes to bigger positive values, y goes to bigger positive values. As x decreases to the left, then the y value would decrease. So now that we've talked about some of the properties here, let's go on and talk about, well, how do we find the equation for this? Now, there are actually a number of ways to represent the equation of a straight line. Probably the most typical way is what's known as the slope-intercept. Okay, so the slope-intercept form is y equals mx plus b. Now, some of you may know this as y equals ax plus b. There are actually any number of representations for this. You can see here I'm saying usually we use the symbol m for slope in North America, but sometimes you'll see it represented as a. And regardless of which one of those you use, it actually doesn't matter so long as you're consistent and careful and know what it is that you're talking about. So we found on the previous page that the slope was equal to 2/3. So we already know that slope value. And this b value is the y-intercept. And so we know that as well from the previous page. That was -5. So putting those together, we can say that y is equal to, the slope is equal to 2/3 times x, and it's going to be plus the y-intercept. So I'm actually going to write it this way, plus the y-intercept, which is -5, but more typically we would say plus -5. We would write that as 2/3 x minus 5. Now there's another form to write the equation of a straight line, and that's called standard form. So here's slope-intercept. Standard form is usually written this way: ax plus by plus c equals 0. So a couple of things. First of all, this is capital B, this is lowercase b. Those are not the same. So this b is not the y-intercept. And this capital A, if you happen to be writing your slope-intercept form, this is a lowercase a. So they're not the same as well. Really, standard form is just a rearrangement of your slope-intercept form. But the way that we're writing this, what we want is we want no fractions. So we're going to do that, and we're going to bring everything to one side. So, and the other thing we want is generally, and this is not a really hard rule, but generally we want a positive A value. Okay, so what I'm going to do is I'm actually going to go over here and I'm going to work on this equation, and I'm going to try to meet these conditions. So I'm going to rearrange this so that everything's on one side. It doesn't matter if everything's on the left side of the equal sign or the right side, but I want to leave only 0. So the first thing I can see here is if I take this y value and I bring it over to the right side, then I will be left with a 0 here. 2/3 x stays the same. I'm going to put that y in between just so I'm writing it in this same order. So this positive y moves over and becomes a minus y, minus 5. Now in order to get rid of this fraction, I've only got the one fraction, and that's over 3. So the easiest way to get rid of a fraction is we're just going to multiply everything by the denominator of that fraction. So I'm going to multiply everything by 3. And so 3 times 0 remains 0. 3 times 2/3, well, the 3's will divide out with each other, becoming 1. So that just gives me 2x. 3 times negative y is negative 3y. And 3 times negative 5 is negative 15. And I could write this to be exactly the same as what I had there. 2x minus 3y minus 15 equals 0. In most cases, the slope-intercept form is going to actually be the more useful for us, just because we're often going to be working with the slope and the intercept. You can go back and forth between these two forms, and sometimes you will be asked to represent your answer in standard form, so you do need to be able to do that. Okay. Moving on from linear relations, we're going to also take a look at a little bit of a review of quadratic relations. We're going to be actually spending quite a bit of time reviewing quadratic relations. So again, if you're following along on the worksheet, this is already included there. So here we have the graph of a parabola. And so we're going to go through the same steps as we did with linear, which is what are the key features? What are the things that we look at here and are noteworthy and might be useful to us in doing some math about this? So let's start with that, and then we'll go on to the equation. So what are some of the properties? And again, the order in which you see these is entirely up to you. It's just whatever kind of jumps out at you, but there are going to be certain properties that you're going to want to take note of. For almost all cases, this point is going to be quite important, and this is known as the vertex. So the vertex of the parabola, and that's a point, has an x-coordinate and a y-coordinate. So that's the way you want to represent that. So it has an x-coordinate of -1 and a y-coordinate of -2, which we're going to represent using our standard point notation. You might look at other important points. In this case, this isn't always the case with a parabola, but in this case we have intercepts. These are x-intercepts. And this is worth noting because x-intercepts are also known as the zeros of the parabola, or they are also known as the roots of the parabola. And in this case, we're going to have the points 1, 0 and -3, 0. So those are my x-intercepts. Another thing related to, and actually it ties these two things together, if I imagine this vertical line that cuts the parabola in two, this is known as the axis of symmetry. So the axis of symmetry is a line. So remember that this is the equation of a line, which means you have to write it as the equation of a line. And so the equation of this line is x equals -1. And as you can see, the x equals -1 corresponds to the -1 of the x coordinate of the vertex. Similarly, the y coordinate of the vertex represents either the max or the min of the parabola. So in this case, our maximum, well, we don't have a maximum. What we have is a minimum. So we have a minimum. And where is our minimum? Our minimum value is -2. So it occurs when y is equal to -2, and that's the y coordinate from the parabola. Now, what are some of the other things you might see from this? Not as useful, but still relevant, would be this point. And that is the y-intercept. You will always have a y-intercept on the graph somewhere, but whether or not it's useful to you is debatable. So and again, as I said on the previous graph, because I've chosen the scale of this, I actually know for a fact that that is at -1.5. So the x-coordinate is 0, and the y-coordinate is -1.5, which of course we could have written as a fraction as well. We could have written that as 0, -3/2. It's never a problem to write these things as decimals so long as they are non-repeating decimals. So long as you can write it precisely, 0.5, 0.1, 0.25, those sorts of things. But you are going to have to be comfortable dealing with fractions. There are going to be parts of this course where you specifically have to use fractions. Okay, so from there, I'm sure there are other things that you might be thinking of right now, and we'll probably cover more of these in class, but these are the really critical properties that I'm going to want you to see when you look at a parabola. So let's go on and take a look at equations. Now, it turns out that there are actually 3 forms of equations that we're going to be interested in with a parabola. Which form you use is going to depend on the information that you have available to you. Now, it turns out that the information that we have from this graph allows us to quite readily come up with 2 of those forms. So the first form that I'm going to look at is called vertex form. And so vertex form is y equals a x minus h all squared plus k, where the vertex is what tells us this h and k value. So the vertex of the parabola is the point h comma k. Now, we knew from looking at our graph that that was -1, -2. So now that we have those values, we can go straight into our equation. Y equals, we don't know this a value yet. It's going to be x minus -1 plus, and the k value is -2. Notice I'm being really careful. I'm using brackets to ensure that I preserve the signs of things, make sure I communicate this really clearly. I also missed a squared here. And now I'm going to continue. X minus -1 is x plus 1, all squared, and then plus -2 we would normally write as -2. Now, the thing I have not addressed yet is this a value. So we don't know what that a value is, and the way that we find that a value is we sub a point. So we sub, let's say, any point that is not the vertex. And the reason we can't use the vertex is that we've already used the vertex in getting the equation to this stage. So if you think about it, this piece of data that we got from the graph is all used up. We can't use it again. We've already used it once. So from here, we're going to choose any other point. So I'm going to go ahead and I'm going to sub, and we had another point here at 1 comma 0, and that's a pretty simple point to work with. So I'm going to sub the point 1 comma 0, and so my y coordinate is 0. So I sub that into my equation, is equal to a, and now my x coordinate is 1. So I sub that into my equation, plus 1 all squared minus 2. Remember, we're doing this just so we can solve for a. So I get 0 equals a. 1 plus 1 is 2, and 2 squared is 4 minus 2. So I get 2 equals 4a. A is equal to 1/2. And now I can write my completed vertex form equation, which means my a value is 1/2. That's coming from up here. My a value is 1/2, and then I just rewrite what I already had there, x plus 1 all squared minus 2. Now the other form that we want to talk about is known as factored form. And that is written in the form y equals a x minus s x minus t. And factored form, what color did I use for this? I didn't. I'll use a color here. In factored form, my s and t values are the x-intercepts. So looking at our graph, we have x-intercepts at -3, and we have an x-intercept at 1. So s and t are the x-intercepts. So when I rewrite this equation, y equals a x minus, but s is going to be -3, and x minus, and t in this case is going to just be 1. I don't need to put brackets around it because it's a positive value. And I'm going to simplify that. Y is equal to a bracket x minus -3 is x plus 3. And x minus 1 just stays as written. And just as we did before, we can now sub a point. Now we can't sub in, just as we used up the vertex, so we can sub any point that's not the vertex. In this case, we can now sub any point that is not an x-intercept, because we have used up the x-intercepts to get to this point, or to get to this form of the equation. So I will go ahead and sub. In this case, I'll just use the reverse. I'm going to use the vertex, since that's an available point. That's the point -1, -2. Sometimes we use a capital V to distinguish the vertex because it's such a very special point. So this would be good communication to actually show it this way. And so my y value is -2 is equal to a times my x value is -1 plus 3. My x value is still -1. In this case, it's -1. -2 equals a. -1 plus 3 is 2. -1 minus 1 is -2. So I get -2 is equal to 2 times -2 is -4a. So a is equal to -2 divided by -4, which is equal to +1/2, which is, not surprisingly, the exact same result we got when we calculated the a value with vertex form, because these are the same a values. So this is going to be x plus 3 and x minus 1. So that was, from this graph, I was able to come up with vertex form and factored form quite readily. If you want to see that again in the note, I've actually gone through this again, maybe in a slightly cleaner way for both vertex form and for factored form. And then the last thing to talk about is standard form. Standard form is simply the expanded form, which is actually we get a lot of our parabolas given to us in standard form, but from something like a graph, it's actually not where we want to start. So if you want to find standard form, you would normally find either vertex form or factored form, and then you would expand and simplify one or both of these to figure out standard form. And I'm going to go through those steps with you. So just to remind you, I wouldn't normally want you to have to do it this way every time, but if this is where you have to start, it's perfectly good, which is x plus 1 all squared is actually the same thing as x plus 1 times x plus 1 and then minus 2. Order of operations says that we're going to do this part first. Now, I'm going to actually be reviewing this expansion in a future lesson, so if what I go through here feels a little bit unfamiliar, it is something that you did in grade 10, I'm going to be reviewing it again, but I'm not going to go through it in a lot of detail right now because it is in an upcoming review lesson. The way I'm going to do this is using FOIL, first, outer, inner, last. So I take a look at the first terms in each of the brackets, and those are both x's. And so an x times an x gives me an x squared. I'm going to look at the outer terms. That's the first term from this bracket and the last term from this bracket. X times 1 is just an x. I'm going to look at the inner terms. 1 times x is an x. And I'm going to look at the last terms. 1 times 1 is 1, minus 2. Now be very careful. This half has to be multiplied into this bracket. Has nothing to do with this negative 2 on the end, and that's order of operations. So y is equal to, now before I multiply anything into that bracket, I'm going to simplify x squared plus 2x plus 1 minus 2. Y equals, now I can multiply in. A half times x squared is just 1 half x squared. A half times 2x, well, a half of 2 is just 1. So that's going to be plus x. And a half of 1 is plus 1 half. But it looks like I'm going to have a fraction here of a half. So I might as well just go ahead and change this into a fraction. So instead of writing this as minus 2, I'm going to write it as minus 4 over 2. And the reason I did that is so now both of my constants have a denominator of 2. And so I get my final equation, which is now in standard form. The 1 half x squared plus x doesn't change, and I have now positive 1 half minus 4 halves. 1 minus 4 is negative 3, and of course that's still over the denominator. So there is my equation in standard form. If I were to do the same thing going from factored form, I would once again, and I should have made a note of this, what did I do? I used FOIL. And I'm also going to use FOIL here. First, outer, inner, last. So x times x is first, that's x squared. Outer is x times negative 1, that's minus x. Inner is 3 times x, plus 3x. Last is 3 times negative 1. Now you might be looking at this and wondering, well, why are we getting different results? And that's because our starting equation was different, and more importantly, the part that we are multiplying together is different. But our final result should be exactly the same. So I'm going to simplify what's inside this bracket before I multiply anything out. Negative x plus 3x is plus 2x minus 3. And this one actually gets us to our answer a little bit more quickly. There's a little bit less algebra involved. 1 half x squared is 1 half times x squared is just 1 half x squared. 1 half times 2x is plus x. And 1 half times negative 3 is negative 3 halves. And as you can see, that final answer is exactly the same as the final answer I got with the other expansion. And I believe that is the end of this first review lesson. I've posted some quizzes from the grade 10 course on the web page. You should be completing a couple of those quizzes for your homework, and also you should be spending some time reviewing the notes from 2D, particularly the notes on linear systems and quadratics.